Yesterday we talked about there are several forms of asymptotes in terms of end behavior. The one that's not on this particular page was the horizontal asymptote. And the horizontal asymptote is just a horizontal line. So, and it's y equals some constant. And when you really think about it, what this is it is degree 0. If I look at it, it is a polynomial. It is a polynomial degree 0. So a horizontal asymptote is degree 0. We talked about one of the asymptotes the other asymptote you're going to be held responsible for is the oblique asymptote. And the oblique asymptote is the guy who is slanted. He's of the form y equals mx plus b. He really is degree 1. And remember, he forms an x, and the graph is either outside the x or he's inside the x. The third asymptote, and you're not responsible for finding it or graphing it in particular. You can find it and you can identify it, but it's much harder to work with. And I called this other, and it's degree 2 or higher. So degree 0 is horizontal. Degree 1 is a line, y equals mx plus b. And anything quadratic or cubic or higher is going to be degree 2 or higher. And that's where we have the quadratic asymptote, which is what this guy was, and the cubic asymptote, which is what this guy was. These are all end behavior asymptotes, and there are 3 of them. The next question comes in is to how do you know about finding them, identifying the type. So the first thing we're going to work on is this. Finding the vertical asymptote from a picture, identifying what type of asymptote we have in terms of end behavior. Of course, looking at the graph, x and y intercepts, that becomes important. Looking at the domain and looking at the range, that's all from the graph itself. So if I look at the first problem right here, I look at this guy. He looks a little bit, and if I had to guess as who he was, this is y equals 1 over x squared, because we saw him yesterday. He looks like he's shifted to the left by 1 unit because he's moved this direction. So that would be 1 over x plus 1, the quantity squared. That would be my guess if I had to guess anything. But first thing we look at is what is the domain. Well, you can see here is a VA. The VA is at x equal negative 1. And VAs are not in the domain, so from the picture, it's all real numbers except for x can't be negative 1. That's the range. Now the range, looks like I have a horizontal asymptote. See, there's a dotted line that's here. This is y equals 0. He's a horizontal asymptote. He's an HA. And the graph appears to be coming down, and he's going to ride along. Y equals 0 is going to be a floor. He doesn't cross it, otherwise it would be in the picture. So it looks like the range is going to go from 0 to infinity, so that y will be strictly greater than 0, but is going to be less than infinity. Or you can say the range would be 0 to positive infinity, not including 0, because it doesn't look like the graph does anything with the HA. Does it have an x-intercept? Well, it doesn't look like it crosses the x-intercept, x-axis at all, so the answer is no. There's none. Does it have a y-intercept? Well, there's your y-intercept right there. And it's x equals 0, y equal 2. The horizontal asymptote is a horizontal line, and it's going to be y equals 0. You write it as y equal x equal lines, because that's what it is. It is a line. The vertical asymptote, that's your VA, that's this guy right here. That's x equal -1. And oblique asymptote. Oblique means I'd have a dotted line that kind of goes, forms an X. And if I already have an behavior asymptote, namely horizontal, you're not going to have another one. So there are none. VA is the vertical wall that the graph never crosses. It can cross the HA, although we're not going to spend much time looking at those in this class. But it would never cross a VA. Now this is the X. Remember the X? So this guy has an oblique asymptote. If I look at it, see here's a dotted line that comes down here. So that's your VA. Your VA is x equals 0. This guy has an OA. So if I look at the domain, the VA basically is the only thing that's not included. So it's all real numbers. X can't be 0. The range is a little funky because it starts here at 2 and then goes to infinity. And then it goes from -infinity, and it appears, so on this side, -infinity, and appears to stop at -2. And there's nothing in between here. So the range would be from -infinity to -2, including, because that's a solid dot, union, and then it starts at this solid dot, 2 to infinity. X-intercept, the graph doesn't cross the x-axis, so there's none. Y-intercept, none, because it doesn't cross the y-axis either. Horizontal asymptote, none, because I don't have a vertical line or a horizontal line. Vertical asymptote, well, we've got a VA, and that's going to be x equals 0. Now the oblique we have to find, and we're going to have to guesstimate, because an oblique is y equals mx plus b. I need two coordinate points, 0, 0, or that's 0, 0, that'll work. Now pick a second point on the line, and it looks to be about right here. They didn't give me another point. And this looks to be -1, 1. Now what's the slope of the line? I'm going to go down 1. I'm going to go over 1. So if I want to find the slope, it's rise over run, which is -1 over 1, or -1. And it goes through the origin, so that's where it crosses the y-axis, and b is 0. So it's y equals m, which is -1, times x, plus 0. So it's y equals -x.